Hi everyone. So the good thing about 4.5 is that this is all techniques and skills that we've been working on for the last couple of days. So these problems, the theme here is just going to be making a common denominator. So we've done this in a few examples in the past. We're going to do a couple more. And then we're going to look at solving some equations that involve identities as well. So looking at this one, sine minus cosecant, there's no need for a common denominator the way that it's written. However, if I change cosecant to its reciprocal identity, cosecant is 1 over sine. So if I put this over 1, I can now make a common denominator of a sine. So over here, I'm going to make sure that I multiply top and bottom. Okay, and again, you want to show all of these steps, show the common denominator that you're trying to make and what you're multiplying to the top and the bottom. Okay, so I can make this sine squared minus 1 over sine. So we want to try and look, is there anything that we could possibly do with this? Well, sine squared minus 1 is not exactly the Pythagorean identity that I need. Okay, but if I rearrange, I can get sine squared minus 1 equals negative cosine squared. So I'm going to go ahead and do that and make the numerator a negative cosine squared. And it's okay to do that, to change up your signs. Okay, so if I split that up on the top, it's cosine times cosine. Well, I could do a cosine over a sine. Which is a cotangent. Okay, so I would say that that would be fully simplified. Let's do one more with a common denominator. So I'm going to change these both into sines and cosines. Which means that the fraction on the left is going to need a sine for the common denominator, and the right side is going to need a cosine. So I have sine squared, and I have cosine squared. So when I put these as one fraction, sine squared plus cosine squared is a Pythagorean identity. It equals 1. Okay, and I think we did this in an example before. You can split this up. 1 over sine times 1 over cosine, which is cosecant times secant. Okay, so that would be more simplified than an addition. Multiplication is always more simplified than addition. So now part 2, what we're going to do, okay, we're going to solve these equations, but first we may have to use our identities to try and simplify the expression before we solve the equation. So you're going to need your trig chart. So you want to try and use your identities first. So I'm going to change my secant and my cotangent I'm going to change those in terms of sines and cosines. Okay, so I'm not doing anything with the root 3 over 2. I'm not trying to solve just yet. I'm trying to use my identities. So I can cancel. I have a 1 over sine. And I can make this cosine squared over sine. So fortunately, these already have a common denominator. I can put them together. And continuing to use my identities, 1 minus cosine squared is sine squared. And I can cancel a sine from the top with the 1 in the bottom. So now I'm trying to solve this equation. Sine of theta equals root 3 over 2. So I'm going to go to my chart, and in the sine row, I'm going to look for root 3 over 2 and figure out, well, what theta is that? So I see root 3 over 2 in the top, 60 degrees, and I also see a root 3 over 2 in the bottom, 120. So 60 and 120 are the final answers for this problem, but I'd also be looking at your simplified expression here and the identities that it took to get to that. So let's try another one. Secant squared minus 1. Anytime that there is a trig identity squared and a 1 involved, I always look for a Pythagorean. So secant squared minus 1 is tangent squared. Okay, and I can cancel. That was a very quick one to get me to my equation. So now on my trig chart, I'm going to go in the tangent row and I'm going to look for positive 1. So the first angle that comes up is 45, and the second one is 225. Okay, that was a nice easy one. Okay, so I would take a GCF out of this. So I see that there is a sine in common. I'm going to take that out, so I have 1 plus cotangent squared, because now 1 plus cotangent squared is a Pythagorean. It's cosecant squared. Okay, I'm not going to get this any more simplified. So if you remember, when we were solving these equations a couple sections ago, and we got to a point here, we could split this up. Actually, I lied. We can do some more with this. Cosecant is the reciprocal for sine. Well, that would be much better. Cancel 1 and 1. 1 over sine. This leaves me with just a cosecant. Much better. Okay, so using the trig chart, in the cosecant row, I have a 2 for 30 degrees, and I have a 2 for 150.